Well, welcome back to the Vintage Tech. It's great to see you again, and thank you for following me. I think I'm up to like 1,400 subscribers, which is pretty cool. And I get lots of emails from subscribers, and communicate with some of you all through email, and have gotten some great repair requests from a number of you, repairing radios and tape recorders and record players and such. So I'm open to doing that when I have time, and so if you're interested in a repair of some piece of sentimental vintage electronics that you'd like me to take a look at, don't hesitate to reach out. I'm currently communicating with a fellow by email, trying to help him troubleshoot a repair, so I do that too, just as a way to give back to the hobby. But today I want to share with you a repair video. We'll call it part one. I'm not going to promise that I'll get to a part two, but the first part of a repair of the little tape recorder that I have done a couple of videos on these, but in particular this repair is something that I'm very proud of. These little memo cords by Stellavox are very troublesome. They have two main issues that occur with these tape recorders, maybe three. The first and probably the most important one is that the motor, the little drive motor in here that runs on 1.5 volts on a AA battery, wears out prematurely. It'll still run, it just won't be strong enough to drive the transport. That's one issue, and without a motor you're dead on arrival. The second issue relates to the transport, and that is that the tires and wheels, we'll call them, wear out, dry out, and crack, and so that there's no grip. Even if the motor did run properly, the tires don't grip, and so it won't pull the transport. A third issue is that the amplifier circuits will fail, need to be recapped usually. Not always recapping, and I've got one on the bench that we're going to repair in this video that has an amplifier issue, and we'll have to solve that in a second video. And then there's a fourth issue that often happens with these tape recorders, and that is that the microphone slash speaker right here, the retainer that holds that microphone and speaker in place to keep it from touching the chassis and picking up the vibration of the motor, that deteriorates completely and dissolves, so the microphone dangles around inside there, and there's no easy way to repair that other than 3D printing a new it looks like a speaker retainer. We'll call it that, speaker slash microphone retainer. And so I've been working on developing one of those, and we'll get to that repair eventually. So the motor and the speed of the tape is adjustable by this little rheostat right here. So there's a wire wound resistor that this adjusts the speed of the tape motor. And at full speed, some of these units will work. Let's see if this one has a battery in it. Yeah, so this one's got a battery in it, and I've got it running at full speed right now, and you can see how it's just barely moving, but it is moving. And I have worked on this for many hours to adjust this, adjust that, tweak this, tweak that, and just barely have the motor running. Now if I drop the speed of the motor down about halfway, see, they stop. It's just, and then when you pull it all the way back up, it will just barely will start back up. So the motor's just lost its power to be able to drive the tape mechanism one direction or the other. Now there's the other direction, and see, it won't even pull the tape. So it's a problem. So I thought, well, what would happen if I replaced the motor with another motor? And then I discovered that those motors don't exist. The motor that's in here is a specialized motor, 1.5 volts, and I started looking for something that was an exact replacement. Those don't exist anymore. And it just, one challenge after another. And so I had given up on it about a year, just completely gave up on it. I have 3 of these, and only one of them works about halfway with the drive. I think that might be this one, and it's just barely working, as you can see. So there might be another one up on the bench that works better. I can't remember. But in any case, they're not perfect, and they need help. The motor needs help. So I thought, okay, now what happens if I found a motor that was strong enough to drive this tape setup at the right speed or close to the right speed, and I could modify the mounting system. Now the mounting system, as we will see in a moment, is pretty clever. It's a rubber housing that holds the motor in place and allows the motor to pivot and ride on the drive, we'll call it the capstan drive control, and then the capstan touches the rim of each one of these spindles and pulls the tape one direction or the other. So as we get into this, it'll become a little bit more obvious how it's working. So I've got at least one video on this where I did a recap and got it working and got the audio to play, but I was never happy with the audio transport, tape transport, and it's because of that motor. So this video, spoiler alert, I found a motor that I thought would work, and so I'm going to walk you through that process of how I converted the motor that's in here to another motor that's easily purchased on eBay. I think I got it from a slow boat from China. I'm not sure. It took a couple weeks to get here, so it probably was a Chinese made motor, and we'll see how it goes. And so it might be a lengthy video in the process of walking through what it took to get the motor to fit and to get the motor to run and get the motor to contact the drive mechanisms and all of that. And then we'll just stop once we get the transport going, if we get it going, and we won't try to repair the audio section of this tape deck just yet. We'll get the transport working perfectly and reliably, and then we'll go from there. But this video is about a motor replacement option for this very popular memo cord tape recorder. I've been on one of these some time ago, well, 3-4 months ago, and I gave up at $50, and it went for $200 on eBay. Oh, I'm not going to give $200 for one of these. Like I said, I've got 3 of them now, and I've probably paid way too much for each one of them. One of these that I've replaced the motor in, I got for less than $50, and that's a lot of money for a little tiny vintage tape recorder. But because they're so tiny and so unique, I just had to have at least one that I could work and convert to a different motor. So that's what this video is about. I hope you stick with me all the way through. And as always, I always appreciate comments in the comment section. And pass the word along. If you have someone that has some vintage electronics that need to be repaired, I may be a good fit. I do some of these kind of repairs, and I do Zenith Transoceanics. I've repaired several of those, and you guys that have sent them to me, you know who you are. And I believe I'm extremely fair with the price. Probably don't charge enough, but hey, the stuff is old, and you can't guarantee the stuff to run forever after you've repaired it because it's vintage electronics, right? So thanks again for watching, and I hope you enjoy this video. Okay, we've got the Stuzzi model 304B that's been having trouble with motors. These tape recorders are extremely unusual, very tiny little things, little double reel to reels, and the motors are pretty slow. I think this one's fired up. Let's see if this one will run. Yeah, you can see it will pull, but it's just barely strong enough to move the tape. So this is one of the working units, and I've got 2 others here that just can't quite pull the tape through. So what I've done is I've pulled the motor out, and I'm hoping that, and the motors are, you can't pull them apart and clean the brushes. So what I've done is I purchased another motor, 1.5 volt motor. They run on 1.5 volts. Oops, forgot to turn that one off. A 1.5 volt pen light battery. And I got another 1.5 volt motor. I don't know if the RPM is going to be too fast. This one has a gear on that I may leave on. This motor engages this driven flywheel, and the motor rides just like that on the flywheel, and this spins, and then this contacts, comes up through, and you can see there it contacts the rim of the tapes. And then however you shift this gear here moves the position of the capstan driver right there to either one of the two reels. So there's 2 points of contact that have to be just perfect. And so what I'm going to do is I've designed and am currently 3D printing a sleeve similar to this. This tip right here broke off, and this retainer. And so I've printed a new sleeve to fit this smaller motor, and I'm hoping in some rubber material, and I'm hoping that that will saddle right into the space. There, it goes right in there. So the motor sits just like that and comes up underneath. This thing flips up this direction, and the tip of that motor touches the rubber drive tire right there, and rides just like that on the tire. So what we've done is we're going to put this smaller motor, but it may be stronger, we're hoping, and it'll set right in there on its new bushing to hold it in place. So I've got that on the printer right now, and we're hoping to get that running here in a few minutes. We'll see how it fits and if it'll set in there nicely, and then drive this driven flywheel. Okay, here's the 3D printed motor sleeve, and here it is. I've got to trim off the supports there and clean up the stringing, quite a bit of stringing, but I'll clean it up, and then we'll slide it onto the motor, see how it turned out. Okay, I've got the motor assembled and put in to its position. Fits beautifully and bolted in. I had to modify the tension spring that holds the motor in tension, so I modified that spring to push the motor up into the driven wheel. And so let's reassemble it here and see what we have. Now remember, I left the gear on the motor, so I'm sure that the motor is going to growl. The gear against the driven wheel here will probably make some noise, but let's see what it does. All right, got the battery in. Low speed. All right, running great. Turning the drive. Let's see what it does here. Look at that. Low speed, high speed. and you can see the outer round tire there. But it's rolling right along really well. And let's put this other spindle in. Temporarily, and switch to track 2. Oh yeah, and I can hold it, but it's pretty tough. Doing great. All right, so that growl that you can hear is going to be a problem. So what we're going to have to do is we can do one of two things to eliminate that buzz. We can put some heat shrink tubing around the gear, but I'm afraid it's going to, the larger that we make the motor, the faster these wheels are going to turn. And I don't want to get them turning too fast, although it would improve the fidelity of the recording. I want it to be, as close as possible to the original speed. So let me let you see this one turning. See if I can get this one to go. You see how slow that turns, and that's on high speed. And that one's working okay for the moment, but that's about how fast they're supposed to turn. Now let's compare that with this one. And it's turning backwards too, isn't it? Yeah, it's turning backwards, so I've got to reverse the polarity on the motor. But look at how fast that's going compared to the other one. But I'm really thrilled with how well the motor is turning and gripping. Now let me reverse the polarity, and we'll see if we could increase the resistance, put a resistor in line with the speed control to drop the speed even more, but I'm not sure just how low that motor needs to run in order to, how low it'll take, how much low voltage it will take before it is not able to spin. But let's try a couple of things. Let's get the direction running in the right direction, and then we'll go from there. Okay, I've reversed the polarity on the motor, so it should be turning this direction. You can see the arrow there on the spindle as the direction, and when it's pulling, that is, and this one, when it's pulling, should be going this direction. So let's try it now. Okay, so we're there we go. Running the right direction. There we go. And didn't change the growl of the motor, which we didn't expect it to. But okay, so let's put, just for giggles, let's put a piece of heat shrink on the motor gear, and let's see if we can get that to quiet down just a little bit. And then what we may have to do is figure out a way to remove that gear without damaging the motor, as I'm sure it's pressed on there, and so we need to rig up some kind of a little tiny puller, but we'll cross that bridge when we come to it. Okay, we can still hear the heat gun in the back there, but there we put a piece of heat shrink tubing over the gear, so we'll see that ought to quiet it down a little bit, and let's see if it helped with the vibration noise or the gear noise. Okay, here we go. Got the heat shrink tubing. You can see it in there on the gear, and let's see if we can still hear the growl when we run the motor. Oh, not bad. Not as bad. Not as bad, but boy, that motor is strong. And it's really, it's kind of centered there in its centered position, so it'll, in neutral, but it kind of vibrates back into drive. But with a tape on there, it wouldn't pull. All right, let's see how this sounds, how this looks. Yeah. See, I'm pulling on it. That tape will move beautifully. It is much quieter. Not as quiet as this one. But the motor's spinning pretty fast. So we definitely need to get rid of that gear. And then we'll have to put some heat shrink. Well, we'll just see. With the gear on there, it's gripping the driven motor really well. And doing a beautiful job there driving those reels. Now here's another factor we can consider. Now it's going to be noisy because remember the microphone is built in right there. The microphone is built into the unit and it's going to pick up that vibration and that buzz when it records, most likely. So we've got to factor that into the repair here. The second thing that we could consider is that as long as you don't switch tapes back and forth from unit to unit, we don't really care how fast this spins. The faster it spins, the higher the fidelity of the recording, because the higher the higher number of inch per second, the better the fidelity of the recording. And if we don't switch tapes from one unit to another, you could do a shorter recording, audio recording on this one, and then just rewind it, manually, like it's designed to rewind, and then play it back, and it would be fine. You just leave the tape on this unit. You got 4 tracks to work with, so that's another consideration, that we may leave the gear on the motor and just deal with the buzz. But I really would like to hear what it sounds like if we can get the motor to mate to the driven pulley, and see if we can get rid of some of that hum of the gear that's still underneath that heat shrink. Plus, we need to get the speed, slow the speed down a little bit without modifying the rheostat circuit. So I think what we'll do is we'll do a little exploring and we'll see how we can pull the gear off of that motor like we have here, and just have and you can see this motor has a brass sleeve on the shaft, and that was probably put on there to adapt the speed, to improve the speed a little bit. It might have been put on there and it was a little bit coarse to grab the rubber tire a little bit better too. I'm not sure why they put that brass sleeve on the old motor. So let's do that. Let's see what it will take to remove the gear on the new motor, and if we can do that without destroying it, then we may have just all the pieces that we need in order to get the unit to run, change the gear ratio, or the pulley ratio, I guess you would say, and on the new setup. Okay, what I've done, I couldn't pull the motor gear off, so I ground it down. I just powered the motor up, and I used the Dremel tool there and just ground it down. And so that's cut the size in half, I'm sure. So that'll help with our speed, and it might help with the buzz. The motor is silent when it runs. I hooked it up to the power, and it's silent. We could continue to grind that down, but you can see that we've taken off all the teeth and we're down to smooth metal now. And so let's put this one in. We'll slide it into this place and solder it, and let's see what it does. In grinding off the gear, the fragments of the grinding crammed in between what's left of the gear, as you can see here, and the bearing, and it caused the motor to bind up. Not completely locked up, but bound up pretty tight. So what I'm trying to do here is to pull those fragments out from behind the what's remaining of the gear. Okay, we got it all back together, and I ground off the gear completely, as you could see from the video that I posted from the microscope. When I had ground some of the gear off, particles got in behind the gear and bound the motor up real bad, and the motor wouldn't run. So I just ground the rest of the gear off of that motor and put a little piece of heat shrink tubing on the end of it, similar to this, except it's just the size of the motor shaft with a little piece of heat shrink tubing on it. So, and now I've got the, tangled tape, because I unwound it by accident, tipping it upside down like that. So we'll rewind it. I'll do that off camera so I can use both hands. Tape back on. Got both reels in with tape. I have an audio board problem, so all we're going to hear, if I hooked up the external power amp, we would just hear a real loud hiss. So I've got some work to do on the amplifier board, but let's get this transport working first. Turn this around, and we have it in moving this direction, pulling on this tape. So let's see how it does. Oh my, it's beautiful. And it's running in slow speed, so we can speed it up. And listen, I've got the fan running in the background, but there's, let me turn the fans off so that you can actually not hear the motor running. Okay, sorry about that. Let's turn it on now. Listen to that. I can't hear the motor running at all. And running slow speed. Now I can hear it a little bit. Just barely. And that might transmit into the microphone. We'll see. But you can see how well it's running. Just beautiful. We can shift gears, go to the other direction. Look at that. Isn't that great? All right, so we've got a successful repair on the Stuzzi's, and this is, you say that's a small victory, but it is a small victory considering these tape decks would be a junk without being able to replace the motor with something that can run on 1.5 volts and carry the freight. So it required a little bit of creativity with a 3D printer and some external work. But these are the smallest tape recorders I own, and that's why I wanted to, reel to reel, that's why I wanted to get them going like new, and I'm very pleased with the outcome. So the next step will be to get this audio board working. That's going to be a separate video because I don't want this to go too long, but I can rest assured knowing that the tape recorder is running beautifully, and it's running a little bit fast. I no problem, no question about it. That motor is running a little bit fast, and so the tape is pulling through a little more quickly than some of the other ones. Let's do another comparison since we have another one running here. So this is running full speed, with the old motor, and this is running slow speed with the other motor. Let's crank this up. So let's do a little count here. I'm going to start counting. 1, 2, 3.5. 3.5 times faster than this tape deck. But I'll bet the audio quality will be superior on this unit as well. And so that's what it's all about. And we're at the end of the tape here now. That's why I stopped. Okay, I'll go the other direction. It's running great. Very pleased with that. Okay, well, we got the transport issue resolved, as you can see here. The new motor and motor mount, and working beautifully. Very, very happy with that setup. So now we need to replace these caps. I'm not sure what's going on. I've got a real loud hiss going on here, but these caps typically are bad, so we'll replace these two caps here, one underneath that transistor, and then there's two over here, another big one here that's a motor cap, and I think there's one up underneath the switch there, as you can see. So we'll get those replaced and see where it goes. And before I do that replacement, I wanted to show you what I'm talking about. I've got this little adapter plugged in right there to the headphone and microphone jack, and then it comes over and hooks up to my little homemade amplifier. So I'm going to turn the amplifier on, and then we'll push play. I've got a battery hooked up to the amplifier, or to the tape recorder amp, and I'm going to push play and you'll hear what I'm talking about. That's the problem. That's the problem. Just got a lot of feedback. So we'll replace these caps and one at a time and see if we can resolve that problem. So there we have it. We got the transport working beautifully, and it's working like a champ. Pulling through just beautifully. And so now we need to fix the audio board. And I'll replace the caps and then see if that solves the problem. I suspect we have a bad transistor. We might have a noisy transistor that's creating that hiss. This is a rather peculiar design. It's a 3 or 4 transistor, 4 transistor amplifier. Pretty simple design. So we'll get into that in another video, but I wanted you to see the successful completion, at least, of the transport repair, replacing it with a different motor, and how we went about creating a 3D printed rubber bushing and modified the tension spring just a little bit. That becomes obvious if you go to the trouble to do this project. You'll discover how you need to just slightly bend that spring to work properly. So we'll get the caps replaced on this. I've started the replacement, and we'll check and see if we need to replace a transistor or two, and we'll try to get the audio working on this in one of my upcoming videos. But thanks again for watching the Vintage Tech. Leave your comments in the area below, and click to subscribe if you're new to this channel, and don't hesitate to reach out to me through email. My email is in my information in the channel, Vintage Tech, and I reply to all of my emails, and I reply to a lot of comments. I read all the comments and respond to questions and those kinds of things. And it's not uncommon to get questions even 2 or 3 years later on some of these repair videos. So don't hesitate to add your comments, questions, information, feedback, advice, whatever you have. I greatly appreciate your interest in this channel of Vintage Electronics. This is the Vintage Tech.